Okay, so besides the terminologies we can use for the file system as well as DBMS, and based on the storage space we mentioned before, in this page we will show how to represent some concrete data elements in the storage space. I think this is correlated with the programming language we have done before, right, for storing some information in the computers. So here the unit of the storage space we have here is called bytes. 1 byte denotes 8 bits, right? And think you can know the difference between these two different units, bytes versus bits. So for storing different information, we probably need to use different bytes for storing them, right? Now for the integers, if we store the short integer, then we need to use 2 bytes. And we need to allocate 2 bytes storage space for storing 1 integer, right? Now here if we have 35, it can be stored into 2 bytes. The first byte is all zeros, and second one will be 00, 1, 0, 0, 0, 1, 1, right? If we want to store a larger integer exceeding the maximum number we can store into 2 bytes, then we can use a non-integer instead, right? It will be 4 bytes instead. And we can store larger numbers. As for real numbers or the floating point numbers, we probably need to store the numbers into 2 parts, right? Now we can use n bits for storing the mantissa as well as n bits for the exponent of the numbers. Now for example, if we want to store the number 1.2345, we can store it as 20,345, right? This is a mantissa, right? We can store this one as with n bits, as a y exponent, which is 10 raised to negative 4, right, as exponent. It also depends on how many bytes we want to store the real numbers. We can either have this float or we have double, right? They will take different storage space. For the float, we need to use 4 bytes, and for the double, we need to use 8 bytes, right? As for charge, we can store it in a different way. For the charge, normally we need to have a coding of the charge. It depends on the language we're using. If we're storing the language in pure English, right, then we probably can do the coding of the charge with a popular ASCII, this code mechanism, right? So every of this charge will be into a ASCII code. For example, we have A, the ASCII code for A will be 1000001, right? As a lowercase a will be 11000001. And for some other language like Chinese or Japanese or Korean or some other language in the Europe, we'll probably need to use some other like a coding mechanism instead, like the Unicode, right, which can encode almost all the language on the planet. Besides the charts, another kind of data we want to store in the database system is about booleans. We can store the boolean with 1 single byte. Now we have true to be all ones, and we can false to be all zeros. And besides the basic data types we have mentioned before, we may also want to store some more complex data types, like the dates. So we can store the dates in 2 different manners. The first manner is to store the date as an integer. It denotes how many days since the January 1st, 1900, which is the standard time we assume to be the starting point for time recording, right? If we have like some dates and which is about 1,000 days since this date, then we can store the dates at 1,000 as an integer. And we can also have another way to store the dates as 8 charts. For example, we can store the dates as years, months, as well as specific day, as a string like year, months, and 2 days, right? This is another way for storing the dates. Besides dates, we also need to store the time as well. Time, I mean the specific hour, minute, as well as second. So we can store this time as an integer as well. It denotes the seconds since midnight, or we can store this one as a charge of a sequence. Now we can have hours, minute, and second. So this is another way for storing the time. Extra string to be stored in a DBMS, it really depends on what kind of string we want to store, right? Because we mentioned before, for strings, they can have different formats, or they can define different types, either the char with a fixed length, or the var char with a maximum length. Normally for the string we want to store in a DBMS, we can terminate the string with some null chars, right? For example, if we want to store a cat, we can just put the cat and we add this null as the ending of the string. And sometimes we can also give the length of the string as well. Like we can give 3 cat, denotes the char, the length is 3, and we provide length in the string as well. And sometimes we can also have this fixed name string, which will be much easier to store, right? Because we know the names for the string. We don't need to add this now to denote the termination of the string. Alright, so this is about how to represent these different types of the data in DMBS. We have mentioned how to store an integer, how to store a float, as well as chars, booleans, the dates, time, and the strings. Next, we'll move to how to store and represent records in a DMBS, which will be more complex to store actually.